Hey guys, welcome to the solution video for the linked list assignment, assignment 9. If you haven't already, please try this assignment before you look at the solution. Um, Try it, and if you get stuck, keep going with it. Be stuck for a couple of days. Sometimes that's what it takes. And that's where you're going to do the most amount of learning is when you get really stuck and you don't know what to do. That's how you do it. That's where a lot of the learning comes from. Um, that being said, if you are stuck and you've given it your best shot and you still don't understand, that's okay. That's what this course is for. It's for you guys to learn and to be better prepared for your futures, right? So don't worry too much if you didn't get it. That's what the solution videos are for, and just take them and try to learn as much as you can from it. Preferably, if you can, just get unstuck, right? So just look at the solution just enough to get going, right? Just to get over that hurdle and then keep going. That's the best way you can do it as well. So anyway, I am going to get into the solution now. So the first thing we have to do is we have to create a constructor for our linked list class. And this constructor takes data n, a parameter called data, and this data can be an array. Okay, so it can be an array, and if it's an array, we have to create a linked list out of that array. Um, if it is not, if it is just a single data value, then um, you just use a single data value, right? You just create a new node. That's what this is down here. Okay. All right. So append to tail, append to head, pretty self-explanatory. You're either appending the node to the end of the linked list, or you are pushing it in front of the linked list. Append from array. Now, here's the trick. Okay, if you see these first four requirements of your assignment, you can actually do them all in almost in one go, really. If you have this one and you have this one, then all you really need is to write append from array using these two, right? So append from array takes in an array and it takes in an argument called head, and it's a Boolean. Head is a Boolean, and you can either make it, if it's true, right? If head is true, then you're going to be appending to head. If it's false, you're going to be appending to tail. And you just throw this in a loop, right? And you can use this method, this append from array, you can use it inside of this constructor. You can do an if check. You can check if the parameter that you're getting, if it is an array, then you can use this. If it's not an array, then you just either one of these would work, right? So that's the trick with this. You can reuse a lot of the methods in here. Well, at least within these three right here, you can make them all work together, so you don't have to repeat your code. Okay, that's the first four. Then we have another method we're going to call that's called print. Print just prints out all of the nodes, and they have to be separated by this arrow. And these arrows should only be between two nodes, okay? So you can't have an arrow in front and then, with nothing before it, like, and then you can't also have an arrow at the very end pointing to nothing. So it has to be in between there. Um, Delete, this one's tricky, okay? This one's a little tricky because once you find the node, you have to account for it so you don't lose your linked list, right? So you don't just have a pointer that is pointing to nothing. And then the longest consecutive value. This method, um, you have to pretty much count and see what the longest consecutive value is. So here we have 1, 1, and then 2, 2, 2, and then 3, right? So these are your longest consecutive values is 2. And that's where you get this 2 from here, and it occurs 3 times, and that's where this 3 comes in. And you just return this as like a tuple, right? As an array with 2 and 3. And that's it. And then this is the node class you guys are given to start off with. Okay, let's go into the code and see what this stuff looks like. Um, so here we have our node class that you already know, and here's our linked list class. So the first thing that we did was we created a head property or attribute, and we set it equal to null. And this is the pointer that's going to keep track of our head, right? So we don't lose it. Then here's that constructor. Here's what I was telling you guys about, right? Remember I told you the append from array, append to tail, and append to head, they all kind of work together. So this is how that looks, okay? So you're going to do an if check here. And yeah, you don't actually need parentheses to do if statements if it's only one line. Some people like to use them and, you know, plop this in here like that. But either way, it's just another way to write the same thing. So just so you know, if you see this, it just means that in if and if else and else statements, if you only have one line, you can write it like this. It's pretty cool. Okay, so here's what we're doing. We're taking in data. We're saying, okay, if array dot is array data, this dot append from array, and we're passing the data in. Okay. Otherwise, we're just gonna set it. We're just gonna take the head. And we're just gonna set it to this new node, and that's it. Right? That's the constructor. Now, let's go into append from array. Okay, append from array. We are taking the array and we're taking the head. But notice there's no head here. We didn't put a head here. Okay, that's because if this is going to end up becoming undefined. Okay, and undefined, if you remember from our previous lectures, that ends up becoming false. It defaults to false. It's well falsy, right? It becomes a falsy statement. So if we don't have anything here, that's going to end up being falsy. And then here we have the array, okay, and which is this data that we pass in, right? But it ends up being an array, and we're going to do a dot for each, right? So this is another way to write a for loop, and you can do it right off of the array. If you know it's going to be an array, you can do dot, and you have a bunch of methods off of it, kind of like push, okay? And here we are passing in a function, right? So you can actually write it like this if you want, or you can write it the other way that I had it. This is the equivalent of that, okay? And you guys have seen this before in the previous lesson, where you can pass in a function to a function. That's what this is. And again, you don't have to write it this way. This is just, I just want to show you guys an alternative way to write loops. There's many different ways to do them, just whatever you like. And you could have just done this in a regular loop, you know, and just put these two statements inside of it. So anyway, so here's what we're doing. We're going, okay, append from array. Okay, if head is true, we're going to append to head. Otherwise, it's just going to append to the tail. And that's it, right? Very simple method. And now this is where the meat of it is, right? Here's the head method and here's the tail method. So the head's going to be a little bit easier to go over. It's a little, obviously, a little more condensed. So what we're doing is, inside the head method, we're going to take the data, and we are going to we're going to create a new node out of the data. Okay, we're using this node class up here. We're going to create the new data, and we're going to say we're going to make the new node. Its next pointer is going to point to the current head. Okay, and so if you can think of it, it's like right in front. Okay, if you can think of the head with all the different links going to the right, but then to the left of the head, this head, there is nothing, right? But what we're doing is we're going to create this new node, and it's going to be like a box, and it's going to be right there on the left side. And then what we're going to do is we're going to say, hey, new node, point to the head, right? Point to our current head. So now the new node is pointing to the head, and now we're going to say, okay, head is going to now equal that new node. Okay, and that's how you do it. It's a very simple operation, but yeah, that's how it works. Um, okay, append to tail. So this one, we have to do a check to see if we have anything in the head, right? That's what this is. We're saying, okay, if head is null, that means there's nothing there. We are going to create the new head just like we would here, right? And we're going to return, and that's it. And actually, you know what? If we really wanted to, we could go ahead and use this method in here, just like so. So this dot dot. You can do it this way as well. Okay. And it'll just do this check. It'll see it's null. It'll create it and it'll return it, and that's it. It'll pop out of the method. Okay. That's the easy case. Otherwise, if head is not null, that means we have stuff. Here we have our temp. Remember from the lecture, you have to use this so you don't lose track of your head pointer, of your head. Okay? That's what these are. These are just pointers. You're just pointing to them. You're just saying, hey, this is going to be here. This is going to be there. And what we're doing is we're saying, okay, while this temp has a next, okay, so while it has a next node, we're going to make temp equal next. Okay, temp is going to be the next one in line. And it's going to keep going. It's going to keep going to all the way to the end. Okay, until this is going to end up being null. Okay, there is going to be a case where this will eventually become null. And when it is, we're going to take it and we're going to set it to the new value. Okay, and that's how you do it. That's essentially how you append a tail, how you append a head, how you do the append from array. You're just looping through it and calling these two, and you can do the same thing in the constructor. Okay, and now we're going to move on to print. Okay, so print, when we call it, we don't have anything here. We're not passing anything in a parameter. We're just going to take a string, and we're going to assign temp to head again. Okay, there's that little trick again. This is very common. You're going to be you use this a lot with linked lists. So what happens is temp. We're gonna loop through, and we're gonna say, okay, while temp does not equal null, we are going to append to the string the temp data. Okay, so we're going to add on to it the plus equals. That's what that means, right? You're used to seeing this with numbers. You can do this with strings as well. Okay, so all we're doing is tacking on. We're tacking this on to the end of it. So we're saying string plus equals temp dot data, and then we're going to go in here. We're going to say, okay, is the next node null? If it is not, we're going to add that arrow. Okay, and this is going to satisfy this requirement here. Uh, should only appear between two nodes. That's what we're doing here. Okay, so we're checking. We're going to add this to the string and we're going to check, hey, do you have a next one? You don't? You do? Okay, great. Put this on. If you don't, we're not going to add it on here. Okay, otherwise it's not going to go on. So then we're going to say, okay, temp is going to equal temp.next. And we do it all over again. Is temp null? Yes or no? Then we're going to say, okay, if it's not, do it over again and over again and over again and over again. That's it. And then eventually we're going to get to a point where this is going to end up being null, right? The next node, we're going to get to the end. This is the last one. We're going to look to the next, and there's going to be nothing there. It's going to be a null. So then we don't do this because it's null. So we don't add to the arrow to the end of it. Then we're going to say, okay, temp is going to equal whatever this next is, which is null. Temp is going to equal null. Well, here, temp equals null. Now it's going to exit, and that's it. And we print it out. We console log it. Okay? And that's how print works. Now, how about data or data? Delete. So delete, here we're going to do a check again. We're going to say, okay, if, and that's what actually this is another a little trick you can do. So you see how here we're doing not equals null. So this is also again using the truthy falsy little tricks you can do with JavaScript. So you notice we had the not operator here, right? So that's the same as saying as this being equal to null. If I can type null, okay? So what we're saying is if this is null, if this dot head is null, return. That's the equivalent of saying this like that. Not if not this dot head. Okay, that's a little trick you can do. Okay, so if there's nothing in here, just return. Don't do anything. Otherwise, we're going to keep going. We're going to say, okay, if the very first element or the very first node inside of our linked list is that data, then what we're going to do is we're going to just say, okay, this head is going to be heads next, and it unlinks the very first node. And that's it. We're done. We return. If it's not that, so it's not empty and it's not the very first one. So now we have to go and we have to search. Okay, this is similar to saying temp. So we're going to have two nodes, or we're going to have two pointers. One's going to be our search pointer and the other one's going to be our trailing pointer. And what we're going to do is we're going to search through the linked lists. And we're going to say, okay, search that next. So while this is not null and while it's not the same data, we are going to have trail equals search, because search is actually ahead of trail, right? Because that's why it's called trail. And search is going to be search.next. Now you got to be very careful, okay? The order of these matter. If you put this one below this one, it's actually not going to trail anymore. Now it's just going to be the same thing that search is, okay? So just be careful with that. And we need this trail for down here, because this trail, we're going to say, okay, it's going to eventually it will either be a null here, or we'll find that data. And this is saying if we do find the data, okay, this is handling the edge case where there's nothing there, okay, where that data, for example, isn't in there. So I don't know, let's say you have one that's 1, 2, 3, and you're looking for 5, right? You're going to keep searching, you're not going to find anything. So you have to check and make sure it's still in there, because we don't know if this stopped. Did this while loop stop um, because this was null, it didn't find it, or did it stop because it found it? And that's what's going to pretty much tell us here, okay? That's how we're checking. We're checking, okay, did you really find it, or did you just get to the end? And if they did find it, now you have to take that trail. Okay, this is why we have that trail one, and you have to make that next equal searches next. Okay, if you don't understand this, then definitely take this code and write it out on paper. Okay, that is how I actually got pretty good with linked list, was writing all of this out on paper and visualizing how those little pointers are moving around, like we did in the lesson. Okay, you can do the same thing on paper. Actually, it's much easier on paper, so than doing it on a computer like I have. Okay, and that's delete. Okay, I know this is a little funky and might be a lot, but that's how you do it. And again, if you don't 100% understand this, take a piece of paper and run through the code, okay, step by step. That's the best way you're going to learn how to deal with linked lists. Okay, now the last one, and possibly the most trickiest, is longest consecutive value. So we have a few setup values here. We have the longest, we have the current longest, we have the current longest value, and we have temp again. Okay. Now what we're doing is we're saying while temp, and remember this is just saying while temp is not equal null. Okay. It's the same thing. It's just shorthand. So while temp is not null, or you can read it while temp is something. While temp has a value. Okay. If if there is no next node and these two are the same, so we're saying the current, so current value and the next value are the same. So there is a next. I mean, this is what this is saying. So if there is a next value and the current value and the next value are the same, then we're going to increase current longest. Okay. Because what happens if you don't have this left side? Um, what can happen is at the very end. So let's say, for example, down here, this was just like this. It would keep going. Okay. And then it would compare to a null, and then you will get it. It'll just puke, right? It just won't work. It'll error for you, because there's nothing next. There's nothing next, right? So that's why you have to have this null check here. So pretty much we're checking and making sure that there is a value, and then we're going to compare the current value and that next value. And if they're the same, we're going to increment the current longest. Otherwise, if they're not the same, we're just going to make current longest equal 1. Okay, this is how you reset it. Then we're going to check current longest. If the current longest is bigger, greater than or equal to the longest, then longest is going to equal the current longest, and the current longest value is going to equal that data. Okay, so that's how you do it. That's how this works. And then again, temp is going to equal the next one, the next node in the linked list. And then at the end, we just return our current longest value and the longest. And again, if you don't 100% understand this, take a piece of paper and run through it in an example, okay? And you can see how it works, because it's all about just moving those pointers around. That's all it is. And it can get mind-boggling when you're first learning it. But it's linked lists are really cool, and they're fairly theoretical. You don't see a lot of it in outside of academia, but I personally I think they're actually one of the cooler. Them and hash maps are really cool. So I like those two a lot. Um, and they're fun. I think these are one of the more fun, more doable algorithm type of questions, in my opinion. And you can also create, and you'll see this in the next lesson, you can actually create a stack or even a queue using a linked list if you wanted to. Actually, it's a very efficient way to do it. Okay, that's it. Let me run my code real quick one time so you guys can see what that looks like. There it is. That's what print looks like. Yeah. So, okay, if you guys have any questions, please let me know. Otherwise, try if you didn't get any of these, try to go through here and try to understand how all of this is written. Okay. All right. See you guys.